So this is a joint work with my colleague, Montserrat Vilalta-Bufi. And what we do here, we investigate, we analyze and try to come up with stylized facts regarding working from home patterns in the European Union countries, some of the European Union countries at least, and investigate the effect of the IT adoption on working from home, understand basically, try to at least do some steps of understanding how much of the changes in the working from home that happened in the past can be explained by adoption of these technologies or changes in the prices of these technologies. What has happened is that recently working from home, I mean, for many of us has gained prevalence, has gained some importance because of the pandemic, because of the lockdowns, at least for a few occupations, at least for a few industries. There has been a rather tremendous change. Many people were able to work from home, and during the lockdown, they were working from home. For example, working from home has increased from around 10% to around 30% in the US during the peak of the pandemic. Similar patterns could hold in the European data. We don't explore that. We don't explore the pandemic period. What we look is what has happened before. So what we establish is that in the European countries, working from home has been increasing in the last decade. There is some evidence from the US. We cite that evidence. There is some evidence from the US, but we established that this has been on a trend, an increasing trend in the European countries. And this is not just an aggregate pattern. We see this within genders, we see within education groups, we see this within age groups, within different types of occupation groups, industries, and so on. This has been prolific. There have been debates what is affecting working from home, as well as in general, the alternative work engagements. And one of the ideas in the literature has been that the information and communication technologies could have been important for working from home patterns. And we try to explore this direction. So we try to understand whether and by how much the information and communication technologies would be responsible for working for trends in the working from home that we observe in the data. A bit more detail, a bit of repetition. So we document a robust increase in the working from home in 14 European countries in the period of 2008 and 2016. We investigate the effect of the fall in ICT prices on working from home, and we are going to use a difference in difference specification in the spirit of Rajan and Zingales. I'll outline exact, yes, this would be our question. So we ask, exactly, this is our question. We ask whether the fall in ICT prices has affected working from home more in industries that depend more on ICT as compared to industries that depend less on ICT. This is the first difference is across industries, high dependence, low dependence, and the second difference is the fall in ICT prices. For us, the fall in ICT prices is going to be an aggregate level variable. This is going to be the shock. Industry differences are going to be exogenous. We are thinking of technological differences of industries on ICT. I'll show you a model, quite stylized, simple model where I'll conceptualize what I exactly mean, saying industry dependence or what the ICT is going to be for us in the model at least. So we use industry and country level data from 14 European countries and the period of 2008 and 2016. So this is a bit more aggregate inference, but it shows at least some interesting patterns at the aggregate level. So what we show is that the share of employed individuals who report that they at least sometimes work from home has increased with the fall in ICT prices. Remember, this is a difference in difference exercise. Later on, I'm going to try hard to convince you about the magnitudes of the numbers. This result holds also within gender, age, and occupation groups. There are no differences, significant differences across, our findings point out that there are no significant differences across gender and occupation groups. To be honest, we were a bit surprised. I was surprised, we were surprised in general. I was thinking that perhaps we would observe stronger patterns for example, for females, but that wasn't the case. Why this could be happening, I'm not so sure. The important thing here is that we are trying to predict what is the effect of the fall in ICT prices on working from home. And this is a differential change across the industries. The aggregate data too actually is not showing much of a difference between males and females. I can show you a table if you are interested in this. The aggregate data is not showing much of a difference. But anyways, quite surprised. I was expecting that for females, there would be a stronger response. That's not the case. But there are differences across age groups and significant differences across age groups. The working from home, the relationship between the fall in ICT prices and working from home is increasing with age. So the ICT is predicting a strong, the fall in ICT prices has a stronger effect for elder groups. Why this could be the case? We have, I'll show you a static version of the model where I'll show you that the preference parameter could play a role, but actually we have a dynamic version of the model where we argue that it could be because the preferences for working from home increase with age, as well as the benefits from working on site decline with age. What could be the preferences for working from home? So young, if I have, if I'm, for example, I'm young, I reside with my parents, I don't have my home. Well, technically what's going to happen is that, my working from home preference is going to be quite low. I'm old, perhaps I have children, older, I'm medium age. I have children, I have my own home. Well, I would like actually to work from home, maybe not as much, I don't know, but there could be a reason of working from home. I'm even further elder, my children are out of the house, they have their own families and so on. Working from home is not is not that difficult for me. I have my own house at least. The other way around, these are speculations. We are not going to test this. I'm going to try to show you some patterns. So I'm trying to give you some ideas why this could happen, but these are mere ideas, conjectures, why this can happen. For younger people, it is quite more important as compared to elder people to learn in the workplace. In such a circumstance, the benefits from working from home might decline with age. Testing this hypothesis can be quite interesting. We try to go in this direction, but the data doesn't allow us to delve much into these questions. These are very interesting issues, but we don't delve into this. So why could it happen that indeed working from home, at least ICT predicts prediction of working from home is stronger for elder cohorts? Of course, we test our results for a very wide range of specification checks, data, restrictions, alternative identifying assumptions, and so on. We delve into this. If you are going to have questions, I'll be happy to try to answer that. Related literature, there have been studies about, this is a big field. I apologize if, I cannot include all, but this is a big field. People have studied various alternative work arrangements, have studied working from home, have studied the effect of IT on labor demand, etc. This is a very big field. A bit of theoretical background, some equations. So what to conceptualize what we have in mind and what type of comparative static we are going to perform in the empirical exercise, as well as how I think about the identification of the effect in this framework. So at the industrial level, the production function is given by this constant elasticity of substitution function, where N is on-site employment, H is employment from home, A is the relative productivity of working from home. Epsilon shows me the elasticity of substitution between these two. We are going to think these are not perfectly substitutable. Neither they are perfect complements. The capital stock at the firm level, at the industry level, is given by this composite with K ICT to power sigma, K N ICT to power 1 minus sigma. This is the total capital stock at the industry level. K ICT is a capital ICT. ICT includes computers, ICT includes all the communication equipment, ICT includes some types of software, etc. KNICT is everything else: buildings, office spaces, tables, etc. Everything else that is employed for production at the industry level. So the industry level value added is generated by labor. Labor can work on site, can work from home, and with capital, part of the capital is ICT, the other part is not ICT. This sigma parameter is going to be important for us. It measures the elasticity of the output to changes in capital ICT. It shows me basically the dependence of an industry on the ICT input, capital ICT input. We are going to assume that the relative productivity of teleworking, of working from home. Here, telework means we're working from home. So we don't we actually observe simply working from home. So A is the relative productivity of working from home. We are going to assume that it increases with the ratio of capital ICT to capital non-ICT. The idea is that computers facilitate working from home. Communication equipment helps to work from home. So the relative productivity of working from home increases with the ratio of capital ICT to capital non-ICT. As the industries adopt more capital ICT, there are more information and communication technologies, the relative productivity of working from home is improving. We'll have basically labor supply. We have consumers here, even though consumption patterns are not of our interest. What is interesting is labor supply. Labor supply is given by this part of the utility function, where what do we have? We have that the consumer likes leisure. It can supply labor to on-site work. This is UN times L. This becomes N. It can supply its labor to on-site work. It can supply its labor to working from home. And it has different preferences over this. The parameter BH% tells me the relative benefit of converting hours into working from home. That includes, of course, the preference of working from home and the potential learning from on-site work. This is very reduced form right now. What I'm saying is that in the paper, somewhere in the appendix, we have a dynamic version of this where actually the consumers can learn at the workplace, and this would be actually affecting their relative productivity. Here, imagine that this is BH is changing. So, for example, older individuals have a higher BH, so they have higher willingness to work from home. From the usual profit maximization problem, it follows that the dependence of an industry on capital ICT, I can measure as this ratio. So I take the ratio of price times capital ICT divided to the price times capital ICT plus the price times of price of non-capital ICT and capital not ICT in an industry. So I have a measure of sigma. I have a measure of what the industry dependence is. I'm going to use data to measure sigma soon. Next, we show in the theory that in the theoretical model, we show that the decline in ICT prices is increasing the ratio of capital ICT to capital non-ICT. When the price of ICT falls, industries are adopting more ICT capital. They are using more of that. This is this comparative study. However, we are not going to look at this comparative study. We are going to look at this one, the difference in difference, double derivative. So capital ICT increases when the price of ICT falls. industries are adopting more capital ICT as the relative price of ICT falls. However, this effect is larger in industries that depend more on ICT. This is the comparison that we are going to utilize to try to think about changes in the demand function. However, the supply side can matter as well. So if I endogenize the supply, I get the employment in working from home. So in general, working from home is given by this equation. When the price of ICT falls, this ratio increases. We have assumed that A increases in this ratio. And because of that, working from home increases. However, that effect is larger in industries that depend more on capital ICT. This is what we are going to identify. Next, this BH parameter plays a role. So the preference or the relative willingness or benefits from working from home plays a role here. If elder individuals have a higher BH, or younger individuals, alternatively, younger individuals have lower BH. In such a circumstance, what is going to happen is that working from home is going to be more responsive to changes in ICT prices for elder people. This is all that I had to say from the theoretical mode. I'll jump into the empirical specification now, the data and so on. So the theory guides our exercise. What we are doing we are going to estimate a difference in differences specification, where difference in difference emerges because we are interacting ICT dependence with ICT prices. On the left-hand side of the specification, we have a share of working from home. This is the number of individuals who report that they at least sometimes work from home. We can, I don't know, weight this by hours of work and so on, etc. We do this as a robust nation. But here, imagine number of individuals in the labor force survey who report that they at least sometimes work from home. This is industry, country, time, level variable. Industries are going to be one digit. Soon I'll show you this. Industries are going to be one digit. We'll have 14 countries and we'll have the time dimension. Next, what we are looking is at interaction of industries' dependence on ICT and fall in ICT prices. So what is this industry's dependence on ICT? I'll try to measure it in the data. This is the sigma. I'm going to think that industries are different in terms of their dependence or production elasticity to ICT capital input. This is this part. I'll identify that from actually the US data. This is time and country invariant. I'm thinking that this is a technological parameter that basically is unique across the industries. Of course, some robustness checks would be to try to identify using European data to allow this to vary across countries, across time, and so on. We do that. But now I'm showing you the case when basically alluding to the case when, not showing, but alluding to the case when this is time and country invariant. Next, we have the inverse of the ICT prices. The idea is that ICT prices are falling, well, the inverse is going to increase. The ICT prices are going to be identified at the country and time level. Actually, in the data, we have also industries. But when we look at the industry level variation in ICT prices, it is super small, suggesting that perhaps at the, the law of one price or the market equilibrates the prices across the industries, ICT prices across industries. There could be some differences if the industries are utilizing different types of ICT inputs, but this is not much. What we have is the inverse of the ICT price. I'll describe what this price exactly is soon. So inverse of the ICT price at the country and time level. Interaction gives us industry, country, time variation. The parameter beta is identifying the difference in difference. So basically what we think is that ICT prices are falling, the inverse is going to increase. And this is actually a hypothesis. This is going to increase the working from home share in industries that depend more on ICT. If we hypothesize this, then we are thinking that the beta is going to be positive. We'll control for country and industry fixed effects as well as country time fixed effects. So our identification is within time, within country, within industry, as well as between time, within industry, within country. So basically, we don't skip entirely the time variation. Why don't we do this? The reason is that the ICT prices have changed a lot over time. So for us, the over time variation is going to be important. The trends are we are going to try to identify things over the trends, even though we can actually set up a bit different specification, look at initial ICT penetration and look at the changes in working from home. So do a different type of different diff exercise and come up with similar estimates. So this is the one that I'm going to show you now. Data, finally, data. The sample includes 13 one-digit industries in 14 European countries and the period of 2008-2016. We obtained the working from home share from the European labor force survey. And this is the trend this is the average of working from home across countries and industries over time. It has changed tremendously. It has basically increased twice over this period. It has increased from, it has increased 1.5 times. It has increased from around 0.9 to 0.5 and something over this period, 0.15 something over this period of time. So it has increased by around 50% over this period of time. It has increased, as I told you. I don't think I have tables here, but if you are interested, I can show you this to you. It has increased similarly across genders. It has increased across, married and non-married, and so many of the demographic groups. It has increased. So whatever demographic we looked, actually, it has increased. We also compute the share of working from home within age groups, young, medium, and old. The young are below 30, medium 30 to 45, well, old, quote unquote old, old in the sense of the sample between 45 and 65. We're going to truncate the sample, and there won't be observations above 65 in the sample. Occupation groups are high-wage occupations, which include managers, professionals, technicians, and associate professionals. And the low-wage occupations are the reminder. The idea is that there has been a recent evidence that ICT are increasing the demand for high-wage occupations. We are going to try to think about this, trying to look at within occupation too. We have also gender. I'm going to report for gender, but there are further results for other demographic groups. Measures for ICT. So what I'm going to use is the price of investments in information technologies relative to the price of non-ICT capital in sample countries. So I observe the data actually are from the EU claims database. I observe the prices of investments into different types of capital inputs. I'll use the price of investments in information technologies and divide this to the price of investments into non-ICT capital input in sample countries. So yes, this measure per se, as I told you, can actually there are data for industries as well, but across the industries there is very little variation. We use the inverse of this measure, and then we expect the beta to be positive. Now, for the dependence, so here, I mean, we are actually following Vahagn and Zingales and many others that are contributing to that literature, but technically we can employ, I mean, we do lots of robustness checks. So the share we use as the measure of dependence, the share of ICT capital in total capital in the US industries. And we average this over the 2008-2016 period. Actually, we observe not so much of changes across the over time of this measure. So taking an average seems to make sense. And in addition to this, what we need is that we need to identify, pin down exactly the parameter sigma with no noise. So arguably, US allows us to do this because the US industries are the leaders in terms of investments in ICT and the level of ICT capital. And US markets tend to be the least regulated. So if there are, what the idea is that if there are some, in the US data, the noise in this measure is perhaps lower than in other countries. We'll, of course, check whether if we use data from other countries, we'll have similar estimates or not. So some working from home patterns, as well as dependence levels, a table data with us. So working from home, this table lists sample industries. The first two columns lists working from home, the average, as well as the change over the sample period. The sample period is 2008, 2016. The averages are taken across time and across countries, and the change is across time. So this is an average within industry. Across countries, we average in 2016 and subtract from that the average in 2008. And we have ICT dependence. What you can observe is that in all industries, working from home has increased. There is considerable heterogeneity across industries in terms of the average of working from home. And actually, the change in working from home explains a lot of this. So for example, if you look at the information and communication industry, you observe that working from home is quite large in this industry. It's around 30% on average. But the change across the time is 15%. So 15% of this 30 has happened over the period of 2008 and 2016, around the 30%, 50% of this change. So roughly speaking, there are some numbers that I have to be more careful with. So of course, this is a fairly large number, and we are going to look whether there are some outliers in the sample and so on, but let's look at the ICT dependence as well. So ICT dependence, for example, exactly for the information and communication industry is very high. So if I took a correlation between ICT dependence and change in working from home, technically it's going to be quite, if you look at the rankings, this is going to be a positive, is showing a positive pattern. Is showing the positive correlation, suggesting that there could be some trend, some effects that are driving these trends across the industries that depend more on ICT, And what is it going to be? Well, we think that this is the fall in ICT prices. If you have no questions here, I'll proceed. So next is the basic statistics for the inverse of the ICT price. And well, this part I'll skip unless you have questions. So the first two columns shows the basic statistics for the inverse of the ICT price. What we observe is that the inverse of the ICT price has increased almost everywhere, meaning that the ICT price has declined almost everywhere. There are some countries where that's not the case, like Italy, Slovakia, UK, in this sample of countries in this period of time. I've had other works as well. The reasons for this can be various. There could have been a shift in the demand and so on for ICT prices. Of course, we'll check that the results are robust to dropping out of these countries from the sample. So the interpretation of this, well, before jumping into estimates, let me try to give you some hints. How much time do I have, by the way?
Well, you can easily present 10 or 15 minutes longer if you wish. It's okay.
Okay, thank you. 10, 15 minutes. Okay, I'll try to give you the interpretation of what we have here. So what I'm presenting is a non-parametric version of the difference in difference estimate that we have in mind. What this figure is plotting, so roughly speaking, the difference in difference estimator that I showed you splits the sample into 4 groups according to the magnitude of the effect of the fall in ICT prices and the level of ICT dependence. These four groups are composed of industry country pairs with high fall in ICT prices and high dependence, high fall in ICT prices and high dependence, high fall of ICT prices and low dependence, low fall of ICT prices and high dependence, and low fall of ICT prices and low dependence. The difference in difference estimator, what it does, it first takes, well, the way you could say, you could take different other differences as well. One of the way of going here is that I take the difference between high dependence industries and low dependence industries in high fall countries. This gives me the green curve. I take the difference between high dependence and low dependence industries of working from home in low fall countries. This gives me the orange curve. The difference in difference parameter beta is identifying the differential slopes of these curves. If the green has a bigger slope, the coefficient beta is going to be positive. This is what our difference in difference parameter is identifying. The difference in slopes across difference groups. What are the difference groups? High fall, high dependence, high fall, low dependence, first difference, and second difference, well, second difference is low fall, high dependence, and low fall, low dependence. I have to take the difference between these groups and look at the trend. The trend, as long as it's positive, so the slope of the green curve is stronger than the slope of the orange, I am identifying the positive parameter. All right. So having said what the non-parametric version of the estimator would have identified, let me go to the parametric version. So we run the regression, and we have an OLS. Well, here I'm presenting an OLS estimate with, of course, industry and country dummies and so on. So country, industry, and country time dummies. There will be many robustness checks with respect to this, but this is our baseline estimate. So the baseline estimate of the beta is 0.737. This is positive, meaning that there is a positive association between the fall in ICT and working from home. A difference in difference estimate, how do I quantify this? How do I think about the magnitude? One way to go is as follows. So I take the beta estimate, I multiply it by the change in ICT prices from 2008 and 2016, averaged across countries. 1. 2, I multiply that by the difference between dependence on ICT in industries that have higher than median dependence on ICT and industries that have lower than median dependence on ICT. I compute this from the numbers that I was showing you. This gives me 0.14. Okay, what do I compare this data with, this number with? I go to the data and look at what happens if I compute similar change in working from home in the data. So I take working from home in high dependence industries in 2016, average that across countries, and average across the industries that have higher than median dependence on ICT. So I have this number in the data. I subtract from that working from home in the same industries and countries, but in 2008. This is the change in working from home in high dependence industries over this period. I subtract from this the difference between the change in working from home over the sample period in low dependence industries. So I get 0.31. What this suggests is that this suggests that around 45% of the variation that we observe across industries, the differential variation that we observe across industries, can be attributed to the fall in IT prices. Okay, we of course run this usual demographic groups, age groups, gender, occupation groups. For age groups, what we observe that there is an increasing, the estimate of beta coefficient increases with the age group. So younger have a lower than medium age, and medium age lower than old, have a lower estimated parameter than old. There seems to be a stronger response among males than females, but this is not statistically significant difference. Why this could be the case could be an interesting thing to explore. I mean, there could be, maybe could be interesting thing to explore. I said that there was no difference across genders. What I meant is that there is no statistical difference across genders. High wage and low wage occupations, there is almost no difference between coefficients, estimated coefficients. Yes, so next what we try doing is we try looking at whether actually married versus single matters for the age groups. The idea is that if I'm young and I'm married, most probably I'll have my own home. And actually, in such a circumstance, I might be behaving in a very similar way as medium age. That is, I mean, in the data, that is more or less confirmed. Such a hypothesis is more or less confirmed in the data. If we look at the single individuals across the age groups, we find almost the same pattern as we observed before. However, if we look at married individuals, young and medium age are not so different anymore. Perhaps, indeed, it could be the case that having a home, we don't observe this, but having a home, perhaps being married leads to having a home. This is a conjecture. So we observe that among young and married individuals and among the medium age and married individuals, the coefficient beta is almost the same. And we have in mind that we think that this could be because young married individuals preference-wise are very similar to medium age married individuals. Well, some other robustness checks exercises. Let me skip this, and if you have questions, I can come back to it. So what we do, we document an increase in the share of employees working from home in a sample of European countries and industries. We find a very strong association of the fall in ICT prices with working from home in these industries. We find very similar results in terms of the direction of the estimate. We find positive estimates for age groups, gender and occupation groups, and but the results reveal significant differences across age groups. And I mean, we have some theory that within the theory we can theorize and try to test some things in this direction, even though it could be an interesting avenue of explorations, perhaps. I'm done at this moment. Thank you.